In the previous tutorial, excuse me, we introduced the concept of functional dependencies, and we said that this concept is absolutely fundamental to normalizing tables. In this tutorial, we will apply the concept of functional dependencies, and we'll try to identify what functional dependencies are present in this table that you're seeing in front of you. And again, we'll reinforce the point that we made in the previous tutorial, that in order to identify the functional dependencies that are present in a table, you have to look at the data in the table, of course, but more importantly, you must have a sense of the rules that operate in the domain represented by the table. So this particular table that you're looking at is a university domain where you have students who are enrolling in courses. So you must know something about how that enrollment process works. Otherwise, just by looking at the raw data in the table, that alone will not be enough to identify the functional dependencies. And we will have more to say about that as we go about identifying the functional dependencies. So just to refresh your memory, the way we represent functional dependencies is using this particular symbol. There is a left side and the right side. So we say X determines Y. X is the determinant and Y is the dependent. So that's the language in which we express functional dependencies. So X determines Y, or alternatively, Y depends on X. So let's go about this table and see what functional dependencies there might be. Now, the first dependency that comes to mind here is G number determines student name. Okay. Now, if I look at this table, what this means is if I give you a value of G number, one value of G number, you can give me exactly one value of student name, which is true in this case. So if I give you G001, you would tell me John Doe. If I give you G0002, you would say Jane Doe. Okay. Now, if I just look strictly at this data, it seems that if I give you student name, you could also give me G number. So if I told you John Doe, just by looking at this table, you would say, well, the G number is G0001. Similarly, if I told you Jane Doe, you would give me G0002. However, I am not inclined to write the reverse. So I don't want to write student name determines G number. I don't want to write this. And why don't I want to write this? Because I know from the way university identification works that a student's G number is unique, but two students could have the same name. So there could be another John Doe at the university, and that John Doe would have a different G number. So if I give you the student name John Doe, in reality, you would not be able to give me a unique G number. So based on my knowledge of the domain, I would not be inclined to write this functional dependency, but only stay with the first one, namely G number functionally determines student name. By the same logic, I would say, the same reasoning, I would say G number functionally determines address. So if I give you the G number of a student, you could give me the student's address. Okay. So now the reverse is not true. So I don't think you can argue. If I give you a value of address, can you give me a unique value of G number? Again, if I look at this, just these four rows that are showing up in front of me, I might be inclined to say address determines G number, because if I tell you the address is First Street, just by looking at this data, you would say, well, the student is John Doe. Similarly, if I give you the address Second Street, you would look at these four rows and say, oh, that's Jane Doe. All right. But in reality, more than one student could be staying at an address, correct? So the first street could be the residence of John Doe. It could also be the residence of Bob Woodward or whoever it is, other people. So in general, knowing the address does not allow you to identify a student uniquely. So it would be incorrect to put this second functional dependency. Notice how I made this determination not based on the data that I'm seeing in the table, but my general knowledge of how students live in apartments. They usually typically share apartments, okay? And that's why a single address may have multiple students in it, and knowing the address therefore will not allow you to uniquely identify a student. Okay, so moving along, another functional dependency that exists is course number functionally determines course name. Okay, so if I told you MIS 310, you would immediately tell me DB is the name of the course. Okay, if I told you MIS 301, you would say IBIS, okay, as the name of the course. All right, so that's pretty much, that's very well clearly understood. If you know the course number, you know the course name. Now the reverse, can I also write this, for example, course name determines course number. Okay, now there's nothing in the table that that tells me that I cannot do this. So if I just look at these 4 rows in the table, I might be inclined to write this second functional dependency as well. Because, for example, if I look at the contents in the table and I tell you, hey, the course name is DB, just based on what I see in the table, you would say the course number is MIS 310. Similarly, if I gave you one value of course name, namely NW, networks, you would say, oh, the course number is MIS 320. However, I know in general, given how George Mason works and also other universities work, I would not write this second functional dependency. Why? Because let's take database, for example. Database as a course, database is offered by the business school. It's also offered by engineering school, okay? And they would have 2 different numbers. So in the business school, it's MIS 310. I don't know what it is in the engineering school, but it would be definitely a different course number. Let's say it's ENGR 310. So it's a different course number, right? Same course. So it's database, but it's offered by the engineering school. It has a different course number. So in general, my knowledge of how university course numbering works leads me to conclude that I can only use this functional dependency, not the second one. Okay, so if I know the course number, then I know the course name. So course number functionally determines course name. So I have at least these 2 functional dependencies. Now, what else do we have? What other functional dependencies do we have? So remember this third theme. If you go back to a previous tutorial, I had said that this table has another theme over here, which is grade. So we have information about courses, we have information about students, and we have information about grades. So there are 3 themes in this particular table. So what about grade? So in order to determine grade, grade is the dependent. Okay, of course, I need to know the student's G number. But knowing just the G number doesn't allow me to identify the grade, because a student may have taken many courses. So at the very least, I also need to know the course number. Okay. But even that is not enough, because a student may take a course multiple times. Okay, so if knowing, so again, this follows from my knowledge of how students take courses at a university. They may take the same course multiple times. So just knowing the G number and the course number is not enough. I would need to know when they took the course. So I need to know the semester. Okay, so once I know the semester and I know the course number and the G number, then I can determine the student's grade. So here are some functional dependencies. So we found this one, we found a second one, we found a third one, we found a fourth one. Okay, and there could be others. So date enrolled, for example. So it looks like, again, I don't know this for sure. So typically a student enrolls in the program on a particular date. So I'm assuming that the G number, if I know the G number, I know the date on which they enrolled. So I would say G number determines date enrolled. Okay, so it depends on what you mean by date enrolled. If date enrolled is when the student entered the program, then of course, if you know the G number, then that uniquely determines the date enrolled. However, if date enrolled means that it's the date on which a student enrolled in a particular course in a particular semester, then of course the student's G number, the course number, and the semester would tell you what the date enrolled is. I hope you're getting a sense of how one goes about identifying functional dependencies in a table, and I hope the discussion that we've just gone through emphasizes to you that it is not enough just looking at the data. Just looking at the data in the table will not give you the full picture. You must have a good idea of the business rules that operate in the environment that is being represented in the table. So if you look back on the reasoning that I offered for these 4 functional relationships that we have just written down over here, a lot of the discussion had to do with my knowledge of how students enroll for courses, how a university operates. So domain knowledge is absolutely important, and that's true for all of these normalization activities.